Hello and welcome to this training. My name is Lorena and I'm here to guide you through the process of how to generate a Kcurve. The content of this training will be: first, we will look at the weaknesses of economic order quantity, which I will be referring along the training as EOQ, and Pareto inventory principle. Then, how the Kcurve addresses the weaknesses of EOQ and Pareto. Third, I will explain the three stages to create the Kcurve. Then, a step-by-step demonstration of how the Kcurve is created for an example of 200 parts. And finally, providing some reasons for why the Kcurve is useful. Let's start with the first section: weaknesses of economic order quantity and Pareto inventory principle. One of the disadvantages of EOQ is that we need to know the cost of order and the cost of holding inventory, which can be very hard to determine in some cases, and it relies on the assumption that the demand is constant over a period of 12 months. Pareto also assumes that the demand is constant, and the division of the whole population of parts between three groups makes it complicated, as this is not sufficient for many businesses. It additionally forces a predetermined percent into each class regardless of what is appropriate for each item. So, to solve the disadvantages of these methods, the Kcurve methodology was developed around the 90s. The methodology was used to set the MRP parameters for IBM's Havan plant in the 1990s and won awards within IBM for its innovation. It addresses the weaknesses of EOQ and Pareto by treating the cost of ordering and inventory holding rate, known as C and I, as a constant in the EOQ equation. So this one's here. 2 times C divided by I. Then this constant is varied between 1 and 100. The Kcurve brings together the strengths of Pareto and EOQ to eliminate their weaknesses and is used in practical applications and industries that handle numerous SKUs. The Kcurve is created by following the three stages below. Stage 1 consists of expressing the EOQ as the economic order period, which I will be referring along the training as EOP. Stage 2 involves building a bridge between Pareto and EOP. And stage 3 is the creation of the Kcurve. So let's go to our fourth section, where I will be showing you the step-by-step demonstration in an Excel file. We are given this data with 200 part numbers and SKUs. In this column, we have the annual usage or demand, and in this column, we have the cost per part. In order to express EOQ as EOP, that's here, I have it here. The first step is to substitute K for 2C times I. So this is our formula of our economic order quantity. And what we're going to do is this one, and this one. We're going to substitute it for K in this formula. So when we substitute, this is the simplified EOQ, and we have the square root of K times D, that is the demand quantity, divided by P, which is the unit cost. This gives us a simplified EOQ. Then we want to convert the EOQ to an order period by dividing the annual demand quantity, which gives EOP in years. So this one here. But we don't want it in years. We want to simplify it even more. So what we do is we clear this one out and we use the number 250. This 250 is the working days in a year based in the 5 working days in a week, appearing in the formula as W. So the final economic order period formula would be W times the square root of K divided by A. If we go into our example and apply this formula, so we can see over here, we have B4, that is 250, our working days. We put this variable fixed. To make this, we just select the cell, and then once we select the cell and put the formula, it appears like B4, but we just click F4 and then we fix that variable so it's stable for the 200 values. Then we multiply by the square root of B3, which is also going to be constant for the 200 values. In this case, it's 30, divided by E18, which is our annual spend value. So once we click enter, we have the EOP for this part, but we want to do it for the 200, so we just drag the formula for around the 200 values. I forgot to mention that here in the annual spend value, what we do is very simple. We just multiply the annual usage or demand times the cost per part for the 200 as well. So I have put a filter as well here just to see the pattern between these two columns, the annual spend value that is in pounds and the EOP that is in days. And we can see that there is an inversely proportional relationship between EOP and annual spend for the items. As the annual spend value decreases, the EOP increases. This mechanism will vary the size of the order in days in direct relation with the annual spend of the part. So for stage 2, we want to build a bridge between Pareto and EOP. We go to this one here that I have. It is more logical to use the cycle days that reflects what happens in practice. So these cycle days have been chosen 5, 10, 20, 40, 80, 160, and 320. Then, for the calculation of the midpoint class boundary, to divide the list of parts into classes, the halfway point between the two EOP values on the logarithm can be used as the switching point from one EOP value to the next. The class limit represents the point at which it will be most economical to switch from class 1, an order cycle of 5 days, to class 2, an order cycle of 10 days. So we have these formulas here. A is the annual demand, K is constant, W is working days, and then here we already calculated the EOP, which here is referred as E. And then we take each annual demand, where EOP is 5 and where EOP is 10 in this case, in this example, and we compare it together. In order to do this, they use the logarithm scale, and they simplify the formula, going from all this longer formula that replaces this one and replaces this one, replaces the logarithm of A1, replaces it here, and the logarithm of A2 replaces it here. So in that way, it's the logarithm of A1 was replaced as W times the constant times E for the annual demand 1, and then the same but for the annual demand 2. This is simplified, and the actual formula that we are going to use is the midpoint demand, this one here, which is the working days 250 to the power of 2 times the constant, in this case is 30, divided by the multiplication between E1 times E2. So in our example, we can see that this one, B4, that is the working days, that one we have it fixed. Then we multiply it again, it's fixed, and then we multiply that one times the constant, which is also fixed, divided by B7, that is the first cycle days, and then B8, that is the second cycle day in this table. We click enter, and then we drag this formula just until the bottom. So for the value class column and the cycle days, we are going to use the following formulas. In the value class, we're going to use the if formula. And basically what it says is if E18, that is our annual spend for that part number, is greater than C7, that is our class limit, then we ask Excel to put the value class 1. If not, then we open another if Excel formula and ask if the annual value spent is greater than 9,375, then put the value class 2. If it is not, then continue. If E18, that is the annual spend value, it's greater than C9, that is 2,344, then put the formula, put the number, the value class 3. And then we continue so on until the end of the table. We just click enter here to see the result. And we have all the value classes. In this case, in this spreadsheet, they're all organized because I have them filtered by the number, I think it is. Yeah, the largest to smallest number. But if it was just like a raw data, you can see that it assigns the value depending on the annual value spent that it has. Then for cycle days, we use a very simple, easy formula, and it's equal choose, which means we're asking Excel to put here the cycle days depending on the value class. So if the value class, we're telling them if the value class is 7, then put the cycle days 320. Otherwise, if it's 6, then put the cycle days 160. And for example, if we go lower over here, if it's 5, put 80, and then we just click enter, and we drag it until the end of the 200. It's important to check here that H18, that is this one here, our value class, that one is not fixed, so that one is not constant. We just leave it as it is. But the rest of the ones that appear in the table here, the cycle days, those ones are all fixed. I mean, they are constant. We leave them constant in the formula. So we just make sure that when we put the number, the formula, we press F4 and make sure that it has these two symbols before the letter and before the number. Once this is done, we just click here, and we can see the cycle days have been assigned as well. So now we are going to add 2 new columns, and we're going to move to another spreadsheet where I have already done this. And is this two here, so the number of orders and the average inventory. To do this, it's a very simple formula. So we multiply the 0.5 times the K18, which is the cycle days, times the E18, which is the annual spent value, and we divide it by, this is a constant in our 200 part numbers, so it's gonna be 250. We calculate this for the 200 of them, and then for the number of orders, we take the working days divided by the cycle days for the 200 of them. So it's a very straightforward 1. And then very important part is that we have to get the total for this one and this one. To get the total, we just use the formula sum, and we select the whole data that we want to add. So it's just the whole column of the number of orders, and we do the same for average inventory. As we can see, this one is when K is 30. So what we need to do now is that we need to change this constant so that we can construct the K-curve after. We can do this in two ways. So one of the ways, the one that I have used, is copy this spreadsheet that I have created and change the value on it. So basically what we do is we just put the mouse on top of this, right click, and then we put move or copy. We want to create a copy, then we click OK. And for example, we want to put the value. This is just an example. For the sake of the example, we're going to put K equals to 40. Oh, sorry, we already have 40. I said 45 probably. Just 45. And here we just change 45. And because all the formulas are connected between each other, we can see that the values of the number of orders, average inventory, and mainly the total number of orders and inventory has changed too. So what I did is copy each of them and just change that value, the K. So here I replace on the top of my spreadsheet, I replace this one for 1, this one for 5, for 10, for 20, until 100. But what we could also do, instead of doing each of them, like each of these spreadsheets, we could create a graph similar to this and just have one spreadsheet. And in that spreadsheet, just make sure that you replace each K with a number, like K equals to 10, K equals to 20, and then check what was the number of orders and average inventory, and then copy to the table. But with that, if I do that, the numbers then can be mixed up, and then it can get confusing, so I prefer to leave them separate. I'm gonna delete this one, that was my example. So I'll show you what I did on K1. I go to the end of the spreadsheet. Sorry, I go to my Kcurve, and then I have K, the number that I assume for K, and then the total number of orders, total average of inventory expressed in pounds. To do this, I just did equal. I go to K1, select this one, that's my cell, and then I just click enter. So in that way, if anything changes in these spreadsheets, it will change here too. So that's quite important. So once we create the table that represents the total number of orders and average inventory for each K value, we are going to create our Kcurve by selecting these ones, the number of orders and average inventory totals, and then we're going to insert and we're going to plot these values in a scatter chart, this one with lines and markers. I like to use the lines and marker ones because I'm able to see where is each K value. So we can have a look here. I have already marked them here as an example. So this is where K is 100. We can see, let's have a look, K number of orders is 1,832, so number of orders is 1,832. Sorry, I was a bit lost. It was here, 1,832. And average inventory is 87,985, so almost 90,000. We can see it's here. And the same for K1, for example. We can see that it's between 700 to 800, so 7,238. and the average inventory is between 32,000 and 40, so 33,650. It can also be seen, oh, well, before I say that, I like to also include in my chart, I just click here in the symbol plus axis title. So it's something very simple, but it makes a difference because you don't get confused what is what. So you can just click in here and change the axis title. I'm just gonna delete this one as an example. So in this curve, it can be seen that the number of deliveries increases as the inventory decreases. It is important to understand what the curve says and how it can be interpreted. The idea is not only to create the curve and that's it, and we don't know what it is to understand the meaning. So if the parts we are concerned with are purchased, the number of orders generated directly equate to the number of deliveries received by the goods in department. If they are manufactured, they will directly relate to the number of changeovers we can perform on the work area. For a machine shop, this will be the number of tool changes, and for a modeling shop, it will be the number of mold changes, and so on, so on. So the number of orders can be set to be the capability of the business to process orders in the work area in questions. So if we are able to confirm a decision with respect to the number of deliveries that we can cope with, we can then simply draw a vertical line and intersect the curve. This will give us the optimum inventory for our capability to process orders. For instance, if management wanted to achieve an inventory of 60,000 pounds, then with the help of the K-curve, we can then simply draw the vertical line and intersect. Yeah, sorry, it's horizontal, but basically it's here vertical, but I'm choosing this first. And then we can see that we will need to be able to process around 280 receipts to achieve an inventory of 60,000 with K set to 45. Well, I rounded that to 45. I guess it's 45, but with the calculation, this can be obtained like at the exact number. So let's go back to our PowerPoint. And let's look at why is the K-curve useful. So by using this approach, we have created a mechanism that allows us to make a rational decision that will fix the EOQ at an optimum value for the business. The K-curve solves the EOQ weaknesses. Instead of needing to find the cost of ordering and cost of holding, we now need to determine the number of batches and/or a target inventory level. Also, when compared to Pareto, K-curve goes from 5 days to 10 days to 20 days ordering, and Pareto goes from 5 days ordering to 20 days ordering. So we can see that K-curve provides a more granular approach. For the same number of orders, a much lower level of inventory can be achieved using the K-curve. Additionally, the value class table allows more subdivisions and allocates the order sizes on economic order principle, which we already saw in this example. What is also significant is that if the value of K is varied, the population in each group will alter, which differs from the Pareto approach as well. So I just want to add here the reference that I used and the acknowledgement. The video was developed by using the figures, formulas, and explanation found in Relf and Milner's book, together with Harry's lecture materials and explanation in class. We have now come to the end of our training. I hope it has been useful for you, not only in the aspect of the calculations, but also understanding the many benefits that this can bring in managing optimum inventory for the business capability. Thank you. Thank you. Bye.